When we talk about big environmental threats, the stories don't usually have happy endings, right? But the one we're going to talk about today is different. It's a story about a massive crisis that we actually, for the most part, solved. So let's dive in. What happened to acid rain?
So picture this. It's 1963, and you've got these scientists out in a forest in New Hampshire. They're just doing their thing, collecting routine rainwater samples. But then they look at their data and realize something is very, very wrong with the rain falling from the sky. And when I say wrong, I mean wow. The rainwater they were testing was nearly 100 times more acidic than it was supposed to be. 100 times. They knew right away that rain like this could literally wipe out entire ecosystems in just a few decades. As you can imagine, this discovery set off major alarm bells, and it kicked off this huge, decades-long investigation to answer two really basic but really important questions. First, what in the world was causing this? And second, how on earth could we possibly stop it? To get to those answers, we first have to break down what acid rain even is, on a chemical level. So all rain is naturally just a little bit acidic. It's got a pH of about 5.4. But the rain these scientists were finding had a pH as low as 3.7. Now, I know what you might be thinking. 5.4 to 3.7 doesn't sound like a huge jump, but trust me, it is a massive deal. And here's why. The pH scale is logarithmic. That's just a fancy way of saying that every whole number you go down the scale, it gets 10 times more acidic. So a pH of 4 is 10 times more acidic than 5. That means the difference between 5.4 and 3.7 isn't a small step, it's a giant destructive leap. So what were the bad guys here? Well, researchers tracked it down to two main culprits, sulfur dioxide and nitrogen oxides. When these gases get up into the atmosphere and mix with water, bam, you get some seriously powerful acids. And where were these gases coming from? I mean, yeah, a little bit comes from natural stuff like volcanoes, but the enormous quantities they were seeing? Nope, that was all us. We were pumping these things into the air in huge amounts from power plants, refineries, and cars, basically anywhere we were burning fossil fuels. And the impact was just devastating. It was widespread. We're talking lakes becoming so acidic that fish just couldn't live in them. It killed off crops and huge swaths of forests. It damaged the soil. It was even powerful enough to literally eat away at stone buildings and metal statues. By the 1970s, the science was crystal clear. But, as we've seen before, knowing what's causing a problem and actually fixing it, well, those are two very different things. And that kicked off a long, drawn-out fight. Scientists were sounding the alarm all through the 70s, but it took all the way until 1990 for real action to happen. The 1980s basically became a lost decade, with the government calling for more research while industry pushed back hard against any new rules. And the arguments they used to delay things were pretty powerful. You had companies saying, hey, it's not our fault, while trying to poke holes in the science. Lobbyists were warning that any regulations would make energy prices skyrocket and kill jobs. And that was enough to convince a lot of politicians to just kick the can down the road. But after that decade of gridlock, Congress finally acted. They amended the Clean Air Act, and the solution they came up with was surprisingly innovative, and it was built on a market-based idea. They put a system in place called cap and trade. The concept is simple but really powerful. The government sets a strict limit, a cap, on the total amount of pollution allowed for an entire industry. Then, it issues a fixed number of permits, or allowances, which companies can then buy and sell to each other. So here's how it played out. First, a firm cap was put on sulfur dioxide emissions. Second, the allowances were handed out. Third, and this is the key part, companies had a choice. They could either invest money to clean up their own pollution, or they could buy unused allowances from a company that was already cleaner. And finally, that cap was designed to get lower and lower over time, which forced everybody to reduce pollution in the long run. Now, not everybody was on board with this. A lot of critics hated the idea. They called the allowances licenses to pollute, and they argued that the government was basically putting a price on clean air. But that economic flexibility was probably the key ingredient that got the policy passed. So, the big question is, did it work? The answer is a huge, resounding yes. This became one of the greatest environmental policy success stories ever. The cap and trade program was just incredibly effective. By taking clear scientific goals and pairing them with economic flexibility, it basically eliminated the acid rain problem across the United States and Canada.
And instead of going out of business like the warnings claimed, the industry innovated. Power plants installed devices called scrubbers to clean their smokestacks. They switched to cleaner fuels like natural gas. They actually developed new, cheaper tech to cut down on pollution. It just worked.
Of course, the story isn't over for the entire planet. While our ecosystems here in North America are slowly recovering, some countries that still depend heavily on high sulfur coal, places like Russia, India, and China, are still struggling with serious acid rain issues today. But the fact that we went from a major threat to a pretty minor issue here is absolutely a victory worth celebrating. It's proof that when policies are guided by solid science and designed to be economically smart, we really can tackle enormous environmental challenges. And that leaves us with a final, really important question. We solved the acid rain crisis. We did it with science, with new technology, and with smart policy. So what can that incredible success teach us about how to confront the even bigger environmental storms that we're all facing today?